So if you look at your notes packet, you see that you have notes regarding odd and even functions, and you should have already read that through. If you haven't, you should stop me, read through the definition of an even function, and read through the definition of an odd function. Okay, so if you look on the left here, I have an even function, and this function is even because it's symmetric with respect to the y-axis. So if I were to take this graph and I were to fold right along this y-axis here, the left side and the right side of that picture will match up with one another. If you look over here on the right-hand side of an odd function is symmetric with respect to the origin. The way I like to think of this one, it's kind of like a pinwheel. And then if you go right here to the origin, let me see. Oh, sorry. So if we go right here to the origin, you'll see that if you rotate the function about the origin, that the picture will look the same whether you turn it upside down or you turn it right side up. So if you were to take your paper and take this picture and turn it upside down, it will look the same right side up as it does upside down. Okay. So now, what I'd like you to actually do, if you don't mind, is if you would take out your packet, like I said, and we're going to just start by doing some of the examples. So if you look at the first one here. Okay, so we have the rule up at the top for an even function. We have the rule up at the top for an odd function. So number one, what you're going to be doing is you're going to be taking notes in your notes packet. So number one has f of x is equal to x to the fourth plus 3x squared minus 10. And if you read the directions, it says to determine algebraically whether the following functions are odd, even, or neither. So algebraically means we're going to use these rules up here at the top. So if you look at the rule for even, it says that f of x is equal to f of negative x. Well, if you look at number one, we already have f of x. So what we're going to do now is we're going to find f of negative x. And basically what that means is everywhere I see an x, I'm going to put in negative x. So I'm going to put a negative x here, and I'm going to raise it to the fourth power. Plus 3 times I see an x, so I'm going to put in a negative x, and raise it to the second power, minus 10. Okay? All right, so I'm going to keep working this out. So negative x, if I raise that to the fourth power, well, a negative to the fourth power makes that positive. And then x to the fourth power just gives me x to the fourth. Plus 3 times, now a negative to the second power is a positive, and then x to the second power is just x squared, minus 10. Then what you do is you look at what we had here originally with what I just got, oops, by doing my f of negative x, there we go, and do you see that they're the same exact thing? So since they match one another, they're equal to one another, this is what we call an even function. Okay? All right. Let's look at the next one. So if we look at this next one here, we have f of x equals 2x cubed plus 2x squared minus 3. All right, well, again, I kind of like to start with just finding f of negative x first. So just like the last one, what we're going to do is everywhere we see an x, we're going to substitute in a negative x. Raise it to the third power, plus 2. There's an x, so I'm going to put in a negative x, raise it to the second power, minus 3. All right, so now we're just going to work this out. Equals 2. All right, now we have a negative here, but it's raised to the third power. So a negative times a negative times a negative is a negative. And then x raised to the third power is x cubed. Plus 2. Then a negative raised to the second power is a positive. And then x raised to the second power is x squared. And then we bring down the minus 3. So we're just going to go one more extra step here. So our f of x will be, well, 2 times negative x cubed is negative 2x cubed plus 2x squared minus 3. Now if you look at these two here, you should look and you should take note that they're not the same. So therefore this function is not even. Okay, so it's not even. So what we're going to do then is we're going to test for odd. And if you read the odd rule on the first page, up at the top there, it says negative f of x is equal to f of negative x. Well, we already have f of negative x right here, so we don't need to do anything with that. Let's do negative f of x. That's really simple. All you have to do is take the original function and you just change all the signs. So that 2x cubed becomes negative 2x cubed. That positive 2x squared becomes negative 2x squared. And that minus 3 becomes positive 3. Now, according to the odd rule, our negative f of x, what I have here in red, should equal what I underlined up here in black. So these two should be equal to each other if it's odd. Now, if you look at them, though, they aren't equal to each other. So this is not odd. Now, what you can do is notice it's not even and it's not odd, so then your answer would be neither. Whoops. There we go, neither. Oh my goodness, pen does not want to work today. Now, I should backtrack for a moment. With number 1 and also with this one, number 2, you can go into your y equals. And really what you should do first is go into your y equals, plug the equation into your y equals, get yourself a graph, and look at it and say, well, is it symmetric with respect to the y-axis? If it is, just test for the even rule. Is it symmetric with respect to the origin? In other words, if I turn it upside down, will it be the same picture, right side up as it is upside down? If it is, then just test for the odd rule. If it's not either of those, not symmetric with respect to the y-axis or with respect to the origin, then you're going to do what I just did right now, and you're going to test both. Okay, so that's kind of like a little cheater shortcut that works. So let's look at the last one, number 3. So now, if we go according to what I just said, I would plug this into your y equals, get yourself a graph, and you should see that this graph is symmetric with respect to the origin. In other words, if I turn it upside down, it looks the same right side up as it does upside down. So then I'm going to go straight to that odd rule, and that odd rule says negative f of x is equal to f of negative x. Okay, so I'm going to start with f of negative x. So remember that means everywhere I see an x, I'm going to put in a negative x, raise it to the 5th, minus 8, I see an x, and I'm going to raise it to the 3rd. All right, so let's do f of negative x. All right, well, a negative to the 5th power, negative times a negative times a negative times a negative times a negative, is a negative. And then x to the 5th minus 8, a negative to the 3rd power is a negative, and then we have x cubed. So then f to the negative x, of negative x, will be negative 3x to the 5th. And then we've got 2 negatives there, so that's going to make that plus 8x cubed. All right, so now let's try negative f of x. Now that's the really easy one. All you have to do is just change all the signs of your original function up here. So that 3x to the 5th is positive, so we're going to make that negative. Okay, and that minus 8x cubed will now become plus 8x cubed. All right, now if we go according to this rule here, right up there, these two guys here should be equal to one another, and they are. So therefore, this is an odd function.